Here we have another vector problem that we see a lot, which is, I refer to it a lot of the time as the ramp question. And so I'm going to demonstrate how you set this problem up. The goal is really to set up a way to get all the forces in and talk about triangles and how that all applies. So it's all going to take place kind of right in here in this general vicinity. We're going to talk about several vectors. One vector that's obvious is the one that you see right there. This one says that there's 2.5 pounds of force pushing up against this package and keeping it from just sliding back down the hill. So I'm going to draw in the vectors and you can pay attention to note where they are. And so we have one vector which we'll call the gravity or the weight of the vector, and it looks like this. So that vector heads straight down. The length that you draw this is kind of irrelevant. It's just got to represent gravity. And so what we look at here, this is essentially what we would consider gravity or the weight of the package. The next thing we're going to do is we're going to draw in what we call the normal force. This is going to be, so back to the gravity one. This one's perpendicular to the actual ground, which is the horizontal value here. The next one we're going to draw is perpendicular to the ramp. You can see that jumping down right here. So this one is perpendicular at that point. This is called our normal force. That's kind of a combination of several different things. Basically, that keeps it down on the ramp and from floating up off the ramp and stuff like that. Not a big deal. The next one we're going to do is considered to be what we would consider the vector that we already have. This is the one for the vectors parallel to the ramp. So this is the force that where you have the 2.5 pounds here. Since it's going just like this, we're just going to kind of represent that in the same exact way down here. The important part here is that what I've been given is this creates a nice little right triangle. If I add in the correct values, this is 2.5 pounds. We also know that the angle measure, the one that we see here at 15 degrees, this one at the very base of the ramp, that's also going to occur right here in between the normal force and the gravity force. So we're going to add that 15 degrees in right there. So that would be 15 degrees. You want to get good at drawing this little triangle that you see. Essentially, if I can draw the triangle, then these questions become quite easy to do in the context that we're going to work in them. So I'm going to redraw the triangle such that it's kind of out away from everything else, so it's not all cluttered. And so what I see here is I have a right triangle. Notice the hypotenuse of my right triangle. You can see here's the right triangle right there. The opposite side of that is always the weight, right? In this particular problem, we're looking to solve for weight, so I'm going to put x right there. We do know that they also told us the angle at the top here. So really what I've done is just kind of leveled out my triangle. It's not perfect, but I'm going to put that angle right up in there. And so go ahead and put that down. That's going to be 15 degrees. And the other force we have is the 2.5 pounds of force. In this case, it's just basic right triangle trig. And so here we have, I have an angle, I have the opposite side, and I have the hypotenuse. So we're going to go ahead and write that out with sine. So the sine of 15 is equal to 2.5 divided by x. Do a little bit of math. You're going to turn out that x is equal to 2.5 divided by the sine of 15 degrees. And that's easy enough. We can calculate that. You can round your answer to the nearest tenth. And that should be sufficient to get your answer. Turns out that 2.5 divided by sine of 15 is about 9.7. So we would say the package weighs about 9.7 pounds, which makes sense. It's not taking a whole lot of force to keep it up there, so I wouldn't expect it to be very heavy. Well, see if you can do this and reproduce the same thing we did. More importantly, drawing this particular triangle without a whole lot of help, this particular triangle is what you want to kind of focus on. If you can do that, then you can pretty much answer this question anytime.